and have out on your desk, let's go please, get those up and in. Let's please have out on your desk your note packet from the other day. We actually have probably maybe a little bit too much to get through today. So we've got to make sure that we work at a good pace. One of the things that we need to make sure happens, let's have your note packets out please. One of the things that you all need to get used to, and it takes a little bit in the beginning, but if you work on it now, it'll get better long term. When you come in and you take that assessment, it's one thing that I find insanely irritating. It's just a general time management thing. So if there's, let's say, 5 questions, you bang out question 1, you got it. Question 2 comes up and you don't know how to do it. Are you going to sit there and spend 15 minutes on it and not get done 3, 4, and 5? I'd say no. You don't know one, that's fine. Go back to it later. Finish the ones that you can do and come back later. You don't want to be rushed sort of at the end. And the other thing is you've got to, particularly with enriched kids, like it is like trying, you will let that test go from your cold, dead body before you'll hand it in voluntarily. You have to be a little bit cognizant of the time and how much we have to do it. There's not going to be a ton of time, and don't stress out over them. Some you'll do well on, some you won't. We didn't get a ton of our notes done from the other day. So if I remember right, did we get these 2 done and this one or something like that? Is that right? Take a look at 1C. Because we didn't do 1C yet. You had to identify your, you might want to have out that factor and check down list that I gave you as well. Oh, calculator. Raise your hand if you got a calculator on your desk. Everybody got one? Great. What we're going to have you all do is this. You can log in now. The other day, remember, I screwed up yours catastrophically. It was terrible. So what you all are going to go through and do today is this. You can log in. Go, when you turn it on, hit 55. Your username is the first letter of your first name and then your last name. So Bob Smith is still going to be B. Smith. So I think this right here is what the usernames are. Now, this didn't say. Yeah, now there's 2, Miss Sarah, both of you have the same last name, right? Yeah, so one's AD and one's AB. Okay? Your password, who remembers what it's going to be? Of the other. Or try this. Well, go through, grab one of the calculators and just take the hood off and try putting that on yours. We'll see. You can be our guinea pig to see if it works. So when your name turns black, that means that you've successfully logged in. But we're going to need you all to make sure that you do that every day. When we do it, and the reason that we do it, have you all, well, we'll say it this way. Who here, none of you have worked with this before? None of you have had to log in? Now, the reason why we do that is because I don't know how to use these calculators all that great. However, this right now is everyone that's logged in's calculator screen. Okay? So, and by the way, another thing that you all do terribly, stop working in Scratchpad. That's not something you should get used to. You need to work in documents. I don't know if people have gone over that before. So go in right now and see how this one here is in Scratchpad, that one there is in Scratchpad. Go in right now, make sure you're always working in a document. So go in right now, never just open a blank new doc. There you go. Choose the network. Oh. There you go. So you can do that. Just make sure you put yours at the top time. Here's one thing. All right, so now that's so you know how to get to a document. Great. That's what you're going to be working with. And as an extra reinforcement, what we'll have you do is go now over to Scratchpad, okay, and start typing in some computations right now. So go over to Scratchpad and start typing in some computations right now. And I'll show you why you shouldn't ever use Scratchpad. Did your calculator screen just get cleared? Yeah. That's because it's not in, you're not working in an ecosystem, let's say. It's literally a scratch pad. Especially when you get to classes beyond this one, like calculus and things like that, You know, sometimes you'll get a really awkward long decimal. You're going to sometimes need to use that exact value and store it into the calculator's operating system. Like save that little bit of a value as a file almost, a mini file, and then use it later on. If you're using Scratchpad, you can't do that ever. And there's actually a ton of features that Scratchpad doesn't allow you to do, and some, I guess it's very, very lazy, and it's a short-term, not well thought out process that they do with you in the beginning. Don't use Scratchpad, use documents instead. But you can set that over to the side because I don't think we have much that we're going to be doing today in there. Take a look. We'll start off, please, at 1C. Hands up, please. We'll see if we can get 5. When you can identify what the GCF in 1C is going to be. Hands up, please, when you can tell me what your GCF in 1C is going to be. We got one person. We'll wait for 5, 2, 3, 4. I'll take that. Who can identify a different? Who had a different answer, I guess, than that? That would work, I think. 1. Yeah, there really isn't anything. It can't be broken down further because, like you said, our GCF is 1. So there's no other common factor really there. We don't count 1 as a common factor. But understand, and this is something that they do a terrible job of explaining to you in the beginning, especially in like Algebra 1. Does every expression factor down? No. You have to make sure you're working from that list. Sometimes it'll be the first one, sometimes it'll be the last one on the list. But not everything breaks down. Let's take a look. We did some of these already. Take a look, let's say, at 2A. Hands up, please, if you can tell me your GCF in 2A. We got 1 and 2. We'll wait for 8. What do you want to say, please? And what's left after you factor out a 3x squared? Now, when you do that, a couple things too. This is not your fault, and I'm not yelling by any means. But we need you to make sure you're saying things correctly. There's a lot of people, even in this building, who use really lazy language, or they talk to you like you're a baby. You guys tend to be pretty, and how old are you again, 15 and 16-ish? 14, 15, 16? So imagine, even when you're 16 years old, and you could be pulled over by a police officer driving a vehicle, but yet we still minimize our expectations for your language. When we're talking about things like this, if you say 3x times 3 plus 4x, that's wrong. Because if you just told me 3x squared times 3 plus 4x, that's what you just told me. How is this different than that? Hands up, please, if you can tell me that. How are those two different? Go ahead, please. There's no parentheses there, so how is our answer going to be different? Yeah, we're not distributing it out. So if you need to distribute out, and I don't know if we said that before, if you need parentheses there, did we tell you what that's called? It's supposed to say the quantity of, okay? So the answer when we say this out would be 3x squared times the quantity of that, meaning it's the 3x squared times all of that, not just the first part of it. We did this one together, is that correct? Okay, now I'm actually going to tell you this next group is a little bit tough, but I think you can get it. Take a look at 3B. Is there a GCF in 3B? And if so, hands up if you can tell me what it is, please. I've got 1, 2. Another thing we have to get over, it's okay to get things wrong. You're supposed to get things wrong. You're getting them right all the time. I'm asking really dull questions. 2, 3, 4, 5. What do you want to say, please?
Quantity of m plus n squared.
Now, not only are you right, but you said it perfect. Now, she did the first part of it, because look at the big expression. This, in and of itself, is one giant binomial. And in that binomial, there's more binomials. This right here is a big binomial, and this is a binomial, and so is that. That's what they both share. What's left if I undistribute that out, or take out my GCF? Hands up, please, if you can tell me that. So you did the hard part. You identified the GCF. What's left? Go ahead. There you go. You've got to identify your GCFs and divide that out or undistributed. Easy way to check. If I distribute out what's on the right, do I get what's on the left? And the answer should be yes, if they're logically equivalent. Now, we actually won't do, let's skip down to D. And D is a very, very good one. Please keep in mind, there's a lot of steps here. This is a good enriched level question. Take a look at what's there to start D. Hands up, please, if you can tell me what the first type of factorization that I could do on D would be. Take a look at that. We'll wait for 6 of you. We got 1 so far. What type of factorization can we do on D to start? Just the first step. I don't need you to be a hero and solve everything. We got 3 people, 4, 5. There. What could you just start it off? In the back, we're going to say.
Oh, I was going to say greatest common factor.
And what is your GCF?
The quantity of p minus 5.
Now, what's left after we divide out the quantity p minus 5? Take a look at the left side and the right side. What would I be left with after I divided a p minus 5 out from both, or undistributed it out, I guess? I've got 1. This is the part. You've got to be willing to take that little bit of risk. It's okay to be wrong. It's good to be wrong. Go ahead.
3 plus 2 minus 3 the quantity of
Just the quantity of 3p plus 4. Why did you need that quantity of in front of it? Who can tell me why he needed to say the quantity of in front of it in this case? There's something we could change where he wouldn't need to have said that. Why did he need to say the quantity of 3p plus 4? And he didn't need to say it for the p plus 2. We got 1 person, 2, 3. There you go. You got to remember that you're subtracting both halves of that binomial on the right. See how this quantity is here? When we put it over here, keep in mind it's minus the 3p and minus the 4. Now we're going to get into just regular simplifying, and this came up in the other section. Somebody asked, so we'll deal with it now. These are brackets here. They're just a second set of parentheses. You could do double parentheses if you want. Now, when we get to there, who can tell me some math that you could do to work this forward from here? What math could you do to work that forward? I can't do that yet. You gave me the second step. I need to state the first. Go ahead. Nope, because that's still in here. There's no more p plus 2s just yet. Let's distribute out our negative. So when we do that, what are we left with in this? Because this p minus 5 is not going to change. What are we left with in here when you distribute out the negative? Yeah, p plus 2 minus 3p minus the 4. Now we're still not done though. What can we do from here? Now is when we put our like terms together. So what's that going to look like to proceed forward? Go ahead. And what's out in front of that? And I look at that though, and I'm not done yet. Anybody see why I'm not done yet? This is the part you've got to be vigilant. We got 3, you see? 4. You're close. I want to put what the 2 of you said, but you're saying something slightly incorrect I don't like at the beginning. We're going to factor out a negative 2. Take a look at the right-hand side. Is there a GCF now again? Yes or no? Yeah. What's our GCF over here? It's a negative 2. So when I do that and I take out the negative 2, leaves me with this. This answer should look awkward to you. You should be looking and saying, this kind of seems unnecessary and kind of out of order. What do I see here that I can do to make it so it's not so out of order or not so awkwardly written. Like if I saw this on your test, I'd look and say, maybe this person doesn't know as well as they think they do, even though they got the right answer. Kind of is a little bit, obtuse or difficult. What could I do to this to give it, I guess, in a little bit better form? Yeah, because with multiplication, does the order matter? No. It should go single terms, monomials, constants, whatever's on the outside, and then we list binomials and then trinomials and so on down the line. So all we're going to do is just put that -2 in front. Now, does the p plus 1 need to go at the end? Does this need to be here? No. Could you move it here? Sure. Now, that question absolutely was a tough one. We do this on the first day of college algebra, which is one class beyond what you currently are in. Was that too much for you to do? No. The toughest thing we asked you to do was identify real tough stuff like, look at the math that you're doing, by the way. You should really be proud of yourselves. You've really extended. We distributed out a negative here. That was really hard. Then we combined like terms. Really tough. Then we recognized a GCF of 2. And then we moved the 2 to the front. That's scrying it. That's not even triggering. There's nothing that tough there, but you got to be vigilant. You got to be working on it all the time. This one's interesting too. Look at example 4. There's 2 ways that we can break this down. What's one type of factorization I can do on 4? Just one. There's going to be more than one answer that's okay. Hands up, please, if you can tell me one type of factorization we can do to start off 4. We got 1 so far. We can get 8. 2, 3, 4, 5. We're getting there. 6. Go ahead. Now, you could factor out a negative a, and what's left when you factor that out? You're right. Close. Just a positive a squared in the beginning there. However, you could also factor out something different. What technically, yeah, just a regular a. And if you took just a regular a out, if you took just a regular a out, that's what you would be left with. Does it matter which one? The answer is no. Which one do you probably want to take out? I would always take out the negative if this will yield a positive leading coefficient here. Because this visually is easier for you to break down if the leading coefficient's 1. Do we have questions on that? Now, the second step that we're going to do today, this is one of the pieces that may be new for this year, I'm not sure, but you're very lucky because you're going to get it explained to you hopefully in a way that makes sense and is not new. Take a look at example 5. When I start off example 5, the first thing that I look at is I go to my checklist. What's the first thing we always look for? GCF. Is there a GCF for those 4 terms? By the way, a GCF or a common factor means that all of them have it. So is there a GCF for those 4 terms? No. Let's work our way down that checklist that you had from the other day. What's the second one? Difference of perfect squares?
Yeah.
Yes. Is this a difference of perfect squares? No. Difference of perfect squares are binomials. This isn't a binomial. Done. Next one up is fast factoring. Look at the examples. Does this match a fast factoring one? Nope. What's the next one on your list? Guess and check. That's when the leading coefficient isn't 1. Does this match that pattern? Yes or no? No. What's the next one after that? Grouping. How many terms are there when we factor by grouping? Looks like a lot of times there's 4. Does this match grouping? Let's give it a try and see if it does. How many times when it says grouping there, what does it say after? Hang on, let me just make sure it's in front of me. Yeah, identify the GCF of the first 2 terms, second 2 terms, and then the expression as a whole. So I'm going to look at my first 2 terms. Now I'm going to look at my second 2 terms. What's the GCF of the first two terms? Hands up if you can tell me that. 5, 6. What's the GCF of just the first two? Go ahead, please. And what's left when you take that out? So far, oh, sorry, group it here. You don't technically need that. So we're to here. Look at the green, the second two terms. Is there a GCF? And if so, what is it? We'll wait for 9. We got 1, 2, 3, 4, 6. What do you want to say, please? What kind to be, positive or negative? Yep. And leaves us with the quantity x minus y. I can't walk away now yet. Why can't I walk away just yet? Who sees what we can do? We got 1. This is why some people, when they teach this, it's sort of like some sort of math magic happens at this point. This should not be that much of a stretch because you got pushed so far on the first couple. I hope you can see what you can still do here. Go ahead. What type of factoring are you doing? Greatest common factor, and what's the common factor in that awkward binomial? The quantity x minus y. What's left when you take the quantity x minus y out? There you go. That was tough. Instead of doing GCF once, you did it how many times? 3. You did it once for the first two, once for the second two, and then once for the whole. Take a look right now. We don't need to, hopefully don't need to go through right now. Give 6 a try right now, please, on your own. Six a try, please. Hands up, please, with what you would do to start with. What's our first line going to look like? Got 1 person? 2, 3? And what's that? Good. And what's left then? Good. And then what else would you do? Perfect. Now, this is going to be, and she made a very wise choice. How many options for a GCF did you just have? 2. What were they? Negative A and positive A. Who can tell me why she correctly chose the negative A as opposed to the positive A? What's the justification there? When we're left, that lead coefficient's positive. Who sees it just a little bit different if you played it out? Yeah. Yeah, if you don't take the right one out, you're not going to have a GCF from the next two. So we did this, took out the negative A, and it left us with x minus y. So can you finish it off what your final would be? Questions on that? Now, sometimes, let's bounce over to question, because we're not going to beat a dead horse here with 7. Take a look at 8. When you do out question number 8, this one's going to be a little bit more awkward. Is there a GCF for the whole expression? Yes or no? The answer should be no. It's not a difference of perfect squares, not a fast factoring. We haven't done factoring by guess and check yet. So we did all of that to get to here. The next one we need to check for is grouping, and grouping at this level tends to happen when there's 4 terms, which there is. As it stands right now, I cannot factor this by grouping. That doesn't mean I can't find a way to give this out as a factor by grouping. In order for us to do factor by grouping, it needs to be that the first 2 terms have a GCF and the second 2 terms have a GCF. Does the order of these matter, by the way? No, as long as we preserve the sign, we're good. Is there a way I can arrange this such that the first two terms would have a GCF and the second two would have a GCF, because it doesn't have that as it stands now. It doesn't mean it can't. How could I arrange this so that the first two terms would have a GCF and the second two terms would have a GCF? I got two people who can tell me. Go ahead.
Oh, well, the negative 10 and the negative 2q squared would be, they would just switch places.
So if you do this out, now you wanted these two to switch.
Yeah, but the 10 also goes to that.
There's more than, and that's why I brought it up, because there is more than one way that we could get to that answer. I arranged it and put it so these first two terms have a common factor and these second two have a common factor. What's the common factor if I arrange it this way from the first two? Go ahead.
Q squared.
And then what's left, please, after you factor out a q squared?
Q squared minus Q.
Great. Now, what can I take out from the second two? What's our GCF for the remaining two? What do you say? 5. And then what's left after that?
Q squared minus 2.
Why was that a beneficial move for us to switch things around?
Because now you can factor out the quantity of e squared minus 2.
Questions on there? Okay. This is really going to be the new stuff for today, and I hope that these are very, very easy for us. Take a look at A. This is our day 2 stuff. Take a look at A at the top of page 3. Let's work down our check down list. First thing we need to always look for is a GCF. There isn't one. Is this a difference of perfect squares in 1A? Nope. Is this a fast factoring? Yes or no? The answer would be yes. I need to find values that are going to multiply to your end value and add to your middle one. So, who knows what two binomials I could have, what our arrangement would be, that are going to have in them numbers that multiply to the negative 35 and add that out. 1, 2, 3, 4. Really? Oh, come on. Go ahead.
Positive 7 and negative 1.
Now, you're correct. What are the factors then going to be?
X plus 7 and
Here's one of the things, guys, that I find so frustrating. Well, we'll get to it in a minute. When you have to multiply those back together, even people in the building do it, I don't understand. They do, I like to call it the rectangle of dysfunction. If you do something like this, right? Is this how they teach you to do things? So,
They tried to get us how to do that, but I
did you
never-
stop? Well, I'll say this. I'll own it. I judge. Do you think Einstein was sitting there when he was a young child going, oh, well, I draw a rectangle and then this is that, and then I add. Come on. Is that what Stephen Hawking is doing when he's proving that black holes exist? No. How do you do these multiplications out? We'll refer to it as a FOIL or a double distribution. Some of you may already be doing it. FOIL stands for first, outer, inner, and last. Let's multiply our first terms together. First and first is going to be x times x, so x squared. O in FOIL stands for outside, which is going to be those two terms. What do we get when we multiply x times negative 5? Well, that's negative 5x. The inside is going to give us a positive 7x. So that's f is first. Outside are the outside 2. The inside are the inside 2. And the L stands for what? What do we think? Last. So let's multiply our last terms together, which is 7 and negative 5. That's negative 35. Does this match that? Yes or no? Yes, it does. That's how you won't ever see me model that rectangle of dysfunction. We do FOIL or double distribution, doesn't matter. If you want to do the rectangle, feel free, that's fine. But we don't model that in class. Go through right now, please, and do 1B. Through right now, please, and do 1B. And I want you to try, actually get up to 3, sorry, 1B, and then 2 and 3. 1B, 2, and 3. Who's got a hint on what we would do for 1B? Or who's got a read on what that answer is? We can get 6 or 7 of us. You got 2, 4, 5, 6, 7. What do you like to say?
20 W plus 4 and W plus 8.
W plus 4 and W plus 8. Let's check to see if it works. First terms, if I multiply those together, give me W squared. What do my outside terms give me? They'll give me an 8W. Inside, give me a 4W. Those combined to give me the 12 we were looking to have. And then we have a plus 32 at the end that comes from multiplying the last terms. Questions on that? Who's got an answer for 2? I think that they can factor down 2. Let's try that out. You said m plus 7 and minus 1. Is that right? So first terms give me m squared. What do the outside terms give me? It would be a negative 1. The inside terms give me a positive 7. So negative 1 and 7 gives me the 6 I'm looking for. What's the problem with that answer? The sign now at the end doesn't match. So everything was going great until we got to that. And this is going to give me a negative 7 at the end. So this can't be our factorization. It's very, very close. Got a different answer. Go ahead. Now I'm going to yell at you right. There you go. M plus 6 and M plus 1. Let's see if that works. First terms multiply together give you M squared. Our outside give us positive 1. Our inside give us 6. So what's 1 plus 6 going to give us? 7M. We need a 6M. So that guy's not going to be it. How else can we... Got another attempt at it. Or what this breaks down to. What would we say? Doesn't factor down. Like we were saying the other day, does everything factor just because we give it to you on a worksheet? No. And by the way, where would you find a strong hint that this won't factor down? This has literally been, and don't get, even the best and the brightest miss this. What lets you know this might not factor? Go ahead. What's that? No? Well, 7 itself is prime, but it doesn't mean that you can't have it in a factoring pair. Yeah, what does prime mean? Yeah, nothing besides 1 is going to go into it. So this is going to be prime. Does that happen? Yes. Remember how we talked before? They don't do a really good job of preparing you coming up. They give you worksheets where everything factors. That's not life. Now, example 3 may be easy and may be tough. Think about, do you have a question for that last one?
So whenever something like doesn't factor down, do we just write prime?
Yes.
Okay.
Okay? Be careful though, because it's not going to be something that you're going to encounter a ton of times, but understand that it's possible for it to happen. Now, take a look at example 3. This one's going to be a little bit awkward, but again, think about undoing that FOIL pattern. A check to see if this breaks down. Let's try some of them. And we might try and we might fail. That's why you have erasers. Now, when we do this out, these express, well, we're going to make 2 binomials. We'll color them in the beginning so you can see. This is the left half of each binomial, and this will be the right half of each binomial. What do you think is going to go in those yellow positions? What do you think would go there? You've got an idea. We can try. If it's wrong, we can erase and move on. An x. And if we put an x there, first terms multiplied together tell me it's going to be x times x, which would be x squared. Now, I probably can fill in parts at the end as well. The values in green, what do they need to multiply to give me? Negative 16a squared. And the arrangement of them is going to give me the positive 6 that I was looking for. This is just a little bit different than you did before. Just got to guess as to what would go in those green spots. You can give it a try. Now, you told me something, but I'm missing something. Is this positive or negative here? Positive. And you did say negative here, right? Let's try out. And if she's right, guess what's going to happen? We walk away. And if not, we're going to erase. First terms give me x squared. The outside terms give me negative 2ax. And the inside terms give me 8ax. What did those come together to give? Positive 6ax. So does that work? Yes, it does. Just be willing to try. And if it doesn't work, you erase and move on. It's not that tough. Questions on that one? That is, you wouldn't even see, I don't think the Reach would ask something that difficult. Take a look at example 4, and hands up please when you can tell me the first thing you're going to want to do in example 4. Go down that checklist if you need to. We'll wait for 8 of you. We got 1, 2, 3, 4, 5, 6, 7. Up. You're right. What'd you say? Yep. What's left after you divide out a 16y from each of those terms or undistributed? Mm-hmm. Yep. One thing, I don't know if you wrote it right, it's a y squared in the start. Okay? Now, why was that a good move for us? What happens from here? One person? Seriously, look at what's there. It's like 7th grade, 7th or 8th grade, when you did fractions. Look at what you're left with. Can we go forward with what remains? The answer is yes. This does factor down. We'll wait for 8 of you that can tell me what your final answer would be for this as a whole, completely factored down. So completely factored, we'll wait for 8. We got 1. Give it a try. Just look at what's left. There's one part that won't break down. That's a 16y. It saves percent. What's the rest of that going to break down to? We've got 2 so far. 3. We're getting there. 4, 5, 6, 7. Always look at what remains. Take it as far as you can go if that's what the question's asking you to do. Do we have questions on this so far? Really, our last type that's going to be a bit of a challenge is this. Now, I'll actually... All right, so we'll do example 5, understanding that example 5 is probably going to be one of the toughest questions, one of the toughest factorings we do, maybe even in this whole beginning factoring unit. So, is there, let's start off with our checklist, is this a GCF? Or is there a GCF? No? Is this a difference of perfect squares? No. Is this a fast factoring? Why not? Yeah, that's the part that's going to make this an Algebra 2 question. Our leading coefficient is 12. That makes things really awkward. And this is the part where the more you do it, the easier it gets. but you have to understand you're going to screw up when you do this. And you're going to screw up very, very frequently, especially in the beginning. Get over it. You will try these types of questions, frankly, taking maybe 3 or 4 minutes each. When I'm breaking this down, in the beginning, I need to have terms that are going to multiply to give me 12r squared. What candidates do I have to go in that yellow position that could give me 12r squared? What are candidates for it? Not what are they, because I'm not going to fill them in right away. We're going to think about just getting a candidate pool before we start picking what our final answer is. We've got 4 or 5 of us. What are our candidates to go in that yellow position? Go ahead.
12R and R.
One candidate is 12R and R. So I list mine out over on the side. So we have a 12R here, and then an R here. So those are 2 of my candidates. Some of you are probably saying, I didn't pick those. And you can be correct. What did you want to say?
3R and 4R.
You could do 3R and 4R. And there's still more. Hands up, please, if you are looking at this and going, they still haven't gotten my pair that I wanted to say up.
6R, 2.
This question, I'm telling you now, is already going to be a nightmare because how many candidates do we have for that yellow position? Really got 3 or 6, depends on how you view it. Why? What number would it be easier to have in front instead of a 12? Sure, 1 would make it really easy, but what besides 1? 6 could be easier, it's got less factors. 2 would be great. I want to see, you know what makes it really easy? Like 17. Why is 17 or 19 or 11 or 5? Why are those values so much easier to work with than this? Those are prime. Now, what is the good part about this question? What kind of number is 2? It's prime. So we know in the blue spot it's going to be a 1 or a 2. Now, what signs do I need to use in order to make this? One's going to be a plus and one's going to be minus. And how did we know that? Because it's got to multiply to -2. Now, this is the part where literally you take a guess and then you check to see if it works. Isn't that even what it's called? Guess and check factor. You take the guess, you check to see if it works. Are we going to get it right the first time? Probably not. Let's try. Let's do 12R maybe and R. And let's do plus. Now, by the way, I already know, well, I'll get to Y in a minute. So I'll put this here. I already know, some of you may even see why this one wouldn't work. Let's try it out though and double check. This automatically, as Enriched students, you should see this can't work. I'll tell you why in a minute. First terms multiply together give me 12R squared. What do the outside give me? What kind of 12? Negative, and the inside give me a 2. So is that going to give me the -5 I was looking for? No. Does anybody see why I wouldn't ever pick this as a guess, though? Something about it that's a little bit awkward. Look at that factor pit. Look at those factors. Why would I not pick those? No? That piece is... Oh, yeah. Look at this. Is there a GCF here? Yeah. So is that going to be a choice ever? No. So let's do this. You all right now, go through on your own, try, and let's see if we can get one. Here's what, I'll let you know what it's going to be. I'll make a really good guess myself, because for some reason I'm shockingly good at this. Let's try it. Here we go. I think we'll do 3R and 4R. And then plus 2 here. And then -1. Is there any common factors, by the way, in those? No? Let's check to see if this works. First terms give me 12r squared. What do the outside terms give me? Minus 3, and then the inside give me a positive 8. So we're close, but is that right? No, it's not right, because what do we get on the inside? We get a positive 5. We need it to be negative. So what do? Switch those signs around. So this would be minus 2 here, and then plus 1. Now will it work? And the answer is yes.
Will they always? Because those both, if you kind of look somehow, they both are 5.
Yeah, well, it's not somehow. Here's the reasoning behind it.
Well, no, the signs are perfect to make -5, but they are.
Yeah, if try it to confirm, but I can't think of a counterexample to when you'd be wrong.
All right.
Okay? So if you got a positive 5, I'm assuming your question was, everything was right except the sign here, so if that's the case, you just change the signs? Is that what you're
No,
asking?
I was just saying, say if you had another equation that's like in this format, are both of the reciprocal parentheses going to be around the number?
Oh, you're saying like local to this
Yeah,
value?
or is it just maybe a
That's it. Not really. The reason that I say I probably, and this comes up, and this is a good, because again, it's guess and check. We had 6, you have 12 possibilities that you could do. And the question was, well, wait a minute, should I try to pick numbers that are close to the 5? Think about what you're going to get if you use a 12 and a 1. And then that outside, if you put a 12 here and a big number here, you're going to get a big number in the middle. You see what I'm saying? So it was a little bit of an educated guess. You can sort of narrow it down or put those later in the queue. Okay? Let's do this. Yeah, so here's the last thing that I need us to go through and do. I need to get from all of you, and this changed it may have changed since I did it the first time. So we'll have you come up by rows. Your homework for tonight. Turn it over. I guess for homework tonight, I think you can handle it. I'll ask you to do this. Get done, please, 1 through 16. I'm not going to give you that tough of ones to do. Okay? Now, what I'm going to ask you all to do is this. I need to make sure that I have everyone in here and your name, like, as you like to be called. So some people are like, Robert, and you go by Bob or something like that. Whatever your name is, you've got to let me know what you actually like to be called. Let's please have so take a look at what's up there. And if your name is good, you just say, all good. If it's not, let me know what you want it in there as. Can I have the first 2 rows slide over? Come on over to me right now so I can and just tell me what your name is. If it's different than what you go by, that's fine. But take a look, and we'll do this. It's not tough to see.
Josh, I go by Josh.
Where are you? Josh, you go by
Yeah.
this one? You go by Josh?
Yeah.
Okay, thank you.
Nick, I go by Nick.
N-I-C-K?
Yep.
Okay. Thank you.
John, I go by John.
Where are you?
Luis.
John, J-O-H-N?
Yeah.
Good? Okay, thank you.
Yeah, mine's Evan.
What's your name?
Jordan?
And you go by Jordan?
Yes.
Is that spelled right?
Yes.
Okay.
Russell Harrison.
And what do you go by?
Russ or Russell. is fine.
Which one? You get to pick.
Russell.
Russell? Okay. And you're good? Okay.
Dylan.
Next 2 rows, come on up.
Justin.
Dylan? Yep. And you're good? Thank you.
Adriana
Adriana, where are you?
on the left.
Oh, okay. And you go by Adriana?
Yeah.
Okay.
Ava Massaro, and I'm actually not on there.
Okay, so let me do this. Ava, A-V-A, M-A-S-S-A-R-O?
Yeah.
That's good?
Yep.
Okay, thank you.
I just go by Amanda.
What's your name?
Amanda.
Where are you? And you're good?
Yep.
Okay.
Just Gavin.
Are you on here? Okay, Gavin, you said? And what's your last name?
I sign up.
Thank you.
And then there's another S in my last name, Christina, on my right. And then a lot of people just call me C.
C?
Yeah.
All right.
I can go by either then.
I'm literally going to just put a C there.
That's
How's that?
fine.
Okay, good.
Mine's good.
Okay, what's your name, honey?
Ashley.
Okay, thank you. Ethan, is that good? Do you go by Ethan? Okay. Do you want to be E or Ethan? You can. Ethan, okay. And you're good?
Yeah.
Okay.
General discussing it's good.
You're good?
Luke
Okay.
is fine.
Which one are you?
Luke Stoll.
Luke, where are you? I don't see it.
Uh,
You go by Luke?
No, I go by Luke.
You just.
right.
It's right? Okay,
Yes.
thank you, sir.
Margaret Nagar, it's Maggie, M-A-G-G-I-E.
M-A-G-G-I-E?
Yes.
Okay, thank you.
Philip, and it's good.
Which one are you, honey?
Philip.
And you go by Philip?
Yeah.
Okay.
Alex, and it's good.
Alex, and you're good? Thank you.
She and I'm good.
You're good? Okay, thank you.
Thank you.
Yep, anytime you want to stop over.
My name is Good, by the way, Sophia
Oh.
Ross.
Sophia, you're good?
Yeah, I'm good.
Okay.
Thank you.
Yep. Do you need to get hours for Geneseo?
Yeah.
What is it, just observing, or are you doing close student teaching? Student teaching? Because they have like observation now, I need to do some of them are just here for like 40 or 60 to observe or something.
I started last semester.
Who are your teachers down there? Is Melissa Sutherland still teaching? And Dr. West is gone, right? Is there a Dr. Wallace that still works there? Who's the stats? Is there Lisa Smith or something like that? She did stats. I see her a lot. Nicodemi and Towsley, they're still there. No Lay Lama, right? So Lisa Lay Lama's gone. Do you have George Reuter at all?
Yeah,
Did you like him or no?
yeah. I've had him every spring semester out at school. He like saved my life last year.
He is so amazing.
Yeah.
And he used to teach high school math over at Canandaigua.
And one of my friends is student teaching there, and everyone's like, he's a legend here.
Oh, he was so amazing. And he got, the thing that was so funny was that he would teach, like volunteer to teach a section of Calc 3, where there was initially like one or two kids that were able to take it. And it ended up getting to be a big thing then to take that as like a senior. But he did that, and like then he would teach like the lowest of the low-level freshmen, like lower than the freshmen that you all have.
Yeah.
And he did it all with a smile. And imagine that juxtaposition the same day you've got kids who can't add versus teaching like Calc 3 and volumes of revolutions and stuff.
I had him for, so like on my first math classes, then I had him for geometry, then I had him for like my education class last semester.
He was the best. I loved everything about him. He was wonderful.
But I had him and Jeff last semester,
Jeff.
honors.
Oh, I never had him. Oh, is Tony McCula still there? Yeah. I had him for Calc 3.
Me too.
And there were so many, so I thought I did terrible. And I actually ended up getting a C+.
Me too.
However, I did go back and I retook it. I thought I would, because I wanted to know what I was doing.
Yeah.
There were just so many literal examples. I think I had like a 14% and that converted to a
It's
C+.
literally the worst.
Just not good. We had, it ended up being, I took it at Brockport, and the lady that I had got a different job somewhere else halfway through. So like the first half of it was going great, I'm finally understanding, and they bring in some guy from like the Ukraine who barely spoke English. And he went back, he taught it just like McCullough did, like all literal examples, and you're like, it just became alphabet soup.
I had like the hardest time with him, like I was a freshman, so like I was taking Calc 3 through some.
I